Hi, welcome to my video on graphing a system of linear inequalities, part 1. When we graph a system of linear inequalities, which is two or more inequalities, we are really trying to solve by graphing, that is, finding the points which fit both inequalities. Let's do some examples to show you what I'm talking about. Here we have two inequalities. Y is greater than a half x minus 2. Y is less than negative 3x plus 4. Let's call this number 1 and call that number 2. So let's look at number 1. Number 1 has a slope of 1/2 and a y-intercept of negative 2. Slope of 1/2, y-intercept of negative 2. So the y-intercept of negative 2, we graph the y-intercept first, which is right there. And the slope is up 1, right 2. Up 1, right 2. Up 1, right 2. So we have the 3 points, and I lay the ruler down, I'm going to draw the boundary line, and I look and see. Here we go. Let's see, up 1, right 2. Trying to line up here. Okay, got it. Notice this is no equal sign, so it's a broken boundary line. There it is, broken. This is supposed to be a space right there. And y is greater than is above the line. So it's above the boundary line. Greater than is above. Again, as I mentioned, that's supposed to be broken right there. And I'll just take a little tiny bit of whitener. Just watch. We'll make it broken. And I'll just do that. And now we have it broken. Okay, so won't be any confusion. And number 2, let's look at number 2. Number 2 has a slope of negative 3 and a y-intercept of 4. So slope of negative 3, y-intercept of 4. So we plot the y-intercept of 4, 0, 1, 2, 3, 4. There's your y-intercept. And we will go, slope is negative 3 over 1. We'll go down 3, right 1. 1, 2, 3, right 1. Down 3, 1, 2, 3, right 1. So let's draw the line that will go through those 3 points. Here we go. Lined up. And again, this boundary line is broken. No equal sign. So it's dash line. There it is. And we have y is less than in relation to this line, less than is below the line. So that's these points come off the line. Everything you got to be careful with. Make sure. And again, this one is going up here. So this is line 1 is this one. Line 2 is this one in relation to boundary lines. So only solved by graphing. What we're doing is finding the points that fit both inequalities. So the points that are above this line and below this one, they are all the points that I'm doing the shading in here. So all the points that are, you just got to be careful. Just, if you ever have to do this, you need like a black marker or something. But so you write down what's the solution if you're solving it. The solution is the double shaded region. The solution when you're solving, the points that are in this quadrant obey both inequalities. The points right here, these points, this one, do not satisfy any of these. So these points here satisfy number 1, and these points here satisfy number 2, but these points here satisfy both of them. And let's do B. So we want to solve this by graphing. So let's call this number 1 and call this number 2. So number 1 has a slope of negative 1/3 and a y-intercept of 2. So if we got a y-intercept of 2, we plot the y-intercept on the y-axis of 2. The slope is down 1, right 3. Down 1, right 3. And we go down 1 again, right 3. And we put our ruler on those lines to line it up, better than drawing a freehand right now. So this boundary line for this line is an equal to, so it's a solid boundary line. Make it solid. There it is, because of the equal sign. Less than is below the line. So that's the graph. So all these points below here, below this line, and on the line satisfy this inequality. Now number 2, which is this one, so this is number 1. Number 2, x is greater than 1 is a vertical line. And it's a vertical line at x equals 1. So we have to make sure, let me put an equal sign right here. Reason is because this line is dark. So let's make this a solid line at x equals 1. Because I have it on one of the grid lines. Let's make it solid because of the equal sign. So x and 1, when you have x and a number, then there's a vertical line passing through the x-intercept of 1. Greater than is on the right side, so there's greater than. So we're looking for all the points that make both true. So as you can see, all the points that are on this line and on this line make the two of these true, and all the points, be careful now, so just draw this a little bit heavier so you can see the shading. So all the points that are in here, on the line and in this area that I'm shading in. So these points satisfy both of these. And so the solution, again, is the double shaded region. Double shaded region. And let's continue. And we have, now practice means pause the video and graph both of these to see if you do it right. Solve by graphing. So here we go. Y is greater than or equal to negative 3. So y is greater than or equal to negative 3 is a horizontal line passing through negative 3. And y is negative 3, 0, 1, 2, 3, negative. So this is the boundary line here is equal sign. So the boundary line is solid. It's a shading. Like that. It's not broken. And y is greater is above the line. So I'm just going to go off at an angle so you can see all the points that start on the line, all the points on this line, and all the points above the line satisfy this inequality. So this is number 1. So this is number 1. And let's look at number 2. So number 2 has a slope of 3 over 2 and a y-intercept of negative 4. So the y-intercept of negative 4 is right here. And the slope is up 3, right 2 from the y-intercept. Up 3, 1, 2, 3, right 2. Up 3, 1, 2, 3, right 2. So let's put a ruler on these 3 dots, line them up, and then we look back and see that this boundary line should be broken because there's no equal sign, so it's broken. So there it is, broken. And now y is less than is below the line. So let's shade below this line. And again, the solution coming off this line. So the solution is the intersection of the two. So the intersection is right here. So all the points on this line right here make both of these true, except this intersection. This intersection is not. This intersection point right here is on this one, but is not on this line. So if I shade in, and there's the horizontal line, so I got to go above that and keep it below the broken line. So you can see as I shade in, again, the solution is the double shaded region. The double shaded region. Number 2, graph. Find the points of intersection of these two inequalities, and let's call this number 1 and this number 2. So let's look at number 1. Number 1 has a slope of a -1/2 and a y-intercept of -3. Slope of -1/2, y-intercept of -3. Remember, we're looking at y equals mx plus b. M is the slope, b is the y-intercept. So this is number 1. The y-intercept is -3, right there. And the slope is down 1, right 2. Down 1, right 2. Down 1, right 2. And this line is a solid line. The boundary line is solid through these 3 points. I have 3 drawn, but there's more. So I have a solid line going through these 3 points. And I have the shade. This is number 1, boundary line. So I have the shade greater than is above. And I'm going to go off at an angle so you won't get mixed up with the lines on the grid. Go further, make sure. Okay, here they are. Now, number 2. Number 2 has a slope of a -1/2 and a y-intercept of +2. So the y-intercept is 2, 1, 2. And the slope is, again, the same, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. So if I plot the line going through all of these points, there I am, right there, and this line has got an equal sign, so this boundary line is solid. So there it is, showing you that it's solid. And this is number 2, boundary line, and I have to shade all the points below this line. So I'm going to come off again at an angle. As you can see, it can get a little bit confusing, but you got to keep in mind that the solution is the points of intersection. So all the points on this line fit both of these, all the points on this line fit both of these, and all the points in between these two. Notice you're up there and you're down here, so the intersection is the double shaded region. It's all the points between these two. But did you notice that these two lines are parallel? Because these two slopes are equal, these two lines are parallel to each other. So we're really shading in like a runway or a highway, a strip between these two parallel lines. So the solution is, again, the double shaded region. And let's turn over. And let's see what the next page has to offer. Here we go. And this time we have 3. Interesting, we have 3 inequalities. Y is less than or equal to 3. Y equal to 3 is a horizontal. X and greater than or equal to -2 is a vertical. So Y is 3 where? Cutting the y-axis at 3. 3 is right here. So this is a horizontal line passing through Y is 3. So that's a solid line here. So there's a solid line. So that's Y is 3, solid. And we shade in Y is less than. So we're looking at all the points below this line. So that fits. This is number 1. This is 2. And this is 3. Now let's graph the second one. X is greater than or equal to -2. X all alone, and -2, that's a vertical line going through -2. So X is -2, 0, -1, -2 right here. Again, I have a solid line on this grid line. So this is a solid line right here. Okay. And because it's vertical, greater than is on the right side. So we're shading on the right side. Now what makes it confusing with the 3 though? We have to pick out all the points that satisfy the 3 inequalities, the 3 of them. So notice we're below this horizontal line, we're to the right of this vertical line, and now we have to look at Y is greater than or equal to X. So number 3, Y is greater than or equal to X, and that's understood to be as 0. So that means I have a slope of 1 and a y-intercept of 0. Because there's no number here, it's understood to be a 0. So I have a y-intercept of 0 right here. And the slope is 1 over 1. So I'll go up 1, right 1, up 1, right 1, up 1, right 1, up 1. I'm just doing enough so that you'll see that I'm going to graph the line, draw the boundary line going through all of these points, and it's an equal to, so it's a solid line. Make it longer so you can really see it. And this is number 3, and we got greater than. Greater than is above the line, so notice the confusion when you do 3. Above, greater than is above, coming off this line. So what set of points is in all of these? Well, remember, we're below this one, we're to the right of this one, and we're above this one. So the solution is all the points that's on this line, all the points on this line, all the points on this part right here, this one, what I'm trying to make dark. And if I could have a black, if I could shade all of this in. So it's the boundary line, it's the sides of the triangle and the interior of the triangle. So the solution is, so I can say the solution is, what's the solution? It's the sides of the triangle and its interior. So the sides of the triangle is A, B, C. So it's the sides of the triangle A, B, C, and the interior of the triangle are all the points that satisfy this system of inequalities. Again, I did this one. I wanted to emphasize the horizontal line, the vertical line, and notice this line is oblique. And if you like my video, click the like button, the subscribe button, and the notification bell because there's more videos coming. Visit my website, www.mathfullyexplained.com to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video.